Alright, so we've got here 3 take away 2x to the power 4, and we know the corresponding coefficients can be taken from Pascal's triangle, and so we've got 14641. We know n refers to the power, so here n equals 4, and we start off from n equals 0, n equals 1, n equals 2, n equals 3, and n equals 4. Okay? And so if we were to expand this out, the basic pattern should be 3, and you write minus 2x. Okay, so it'll be 4 to the 0, 3 minus 2x to the 1, 3 minus 2x squared, 3. Can you quiet down, please? Excuse me. Okay, and then 3 to the 0 minus 2x to the power 4. And then we can put the Pascal's coefficients in. It's 1, 4, 6, 4, and 1. Okay? We're going to then tidy each of these terms up, and that would obviously just give us 0. So you've got 3 to... Right, so what do we get for the first term?
81.
81. What do you get for the next term, Adi?
Minus 216x.
Minus 216x. Did anyone else get that? We all agree with that? Okay, for the third term, Amy? Plus 216 x squared. Okay, the next term, Laurentio? Minus 96x cubed. Do we agree? Zane, do you agree with that? Okay, wisdom, what's the last one? Plus 16x to the power 4. Hands up if you got that? Okay, great. Right, what we want to do, however, you know, if I were to raise the power to 40, and I said work out the first 4 terms, right, it raises the stakes, and then you've got a lot more at play. So what we want to do is be able to do the whole thing, but in a shortcut way. Okay, so what I'm about to show you, because C1 is a non-calculator, is just show you a series of shortcuts that allows you to do some of these calculations, especially when n is large, you know, with relative ease. But before we look at the shortcuts, we need to understand what we're taking a shortcut to. So what I'm going to first start off by doing is actually just giving you a formula for the coefficients given by Pascal's triangle. Okay, and then I will then show you how various shortcuts apply to that. Okay, so you need to make sure you like paying attention, and you take this stuff in. The first thing is the Pascal's coefficients or really the Pascal's numbers, yeah, which are the coefficients, are given by a formula. The formula is like this: NCR. Okay, NCR. And another way to write it is like this. And the formula for it is n factorial, I'll explain what that is in a minute, times r factorial times n take away r factorial. So, to give you an example, if I'm going to work out the third term, which we know is 6, yeah, we can see that from here. The third term when n equals 4. So if I had to work out 4c3, is that correct? Sorry. So if I was to work out, if I want to work out this number 6, what term number would that be? Not the third. We start counting from 0, 1, 2. So it'll be our second. So we'll put 4c2. And if we plug that into the formula, that means 4 factorial divided by 2 factorial times 4 take away 2 factorial. This factorial should actually be outside. This is n take away r. Sorry, let me just rewrite that. It's n take away r factorial. So this means it's 4 factorial divided by 2 factorial times 2 factorial. 4 factorial means 4 times 3 times 2 times 1. And 2 factorial means 2 times 1. And 2 factorial means 2 times 1. Straight away, I can make my life easier just by cancelling the 2 times 1. And 4 times 3 is 12, divided by 2 gives us 6, which is what we've got.
Why is it that it's not flatter?
Because the way the equation is set up and the whole thing works, and the way Pascal's triangle is arranged as well, is we start from 0. So even when we're talking about the roll number, we wouldn't say this is the we wouldn't say this is a 5th row, we'd say it's a 4th row, because we start from 0. So the columns and the rows, or rather the rows and the terms, begin from 0. That's a really important point, otherwise we'll get it wrong. Okay? Alright, let's do another one. In fact, what I'll do is I'll give you a couple to do. Let me just put that up there. And let me just put this down. Can you have a go at these questions here, please? Have a go at that. I'll give you a minute and then we'll go over it. Okay, so what I'm going to do, guys, is guys, can you just look up for a second? Just to show you how it works on the calculator. Okay, just to check. Obviously, in the C1 you don't have a calculator, but you know, obviously, if you've got a question you want to check, you just do 6, shift, divide, and 3. Press equals. That gives us 20. So for the first one, we've got 20. For this next one we've got 10 C8. That gives us 45. And then we've also got 10 C4, and that gives us 495. Is that correct? Did I put 12? Yeah, 12 C4 gives us 495. Okay. So that's just to show whether you've got the right answer or not. Yeah.
So what's this calculator? Wait, is this in C1?
All right. So let's go over this, and as we go over it, you need to really look up, because what I'm going to be doing is not just doing the calculation but showing you a few tricks. So I've got 6C3. I know this is 6 factorial divided by 3 factorial times 6 take away 3 factorial. Right? Now this is 6 times 5 times 4 times 3 factorial. I don't need to write 3, 2, 1. I've stopped at 3 factorial because I've got a 3 factorial here at the bottom. And then I've got 3 factorial there. And then that can cancel with that. And so I'm left with 3. Now at the bottom, 3 times 2 is 6. Times 6 times 5 times 4. So that cancels with that. And I'm left with 5 times 4, which is 20. So a lot of it is just about cancelling off. Now the second one is a really important one. Can everyone just make sure you look up? Now the next one involves a really nice little trick, and it works like this. So I can summarize the mathematical shortcuts you need to take just really through the second example. So I've got 10C8. If I was to write that down, it'll be 8 factorial times 10 factorial. So this is what we've got. Times 8 factorial times 2 factorial. Is that right?
Yeah.
Okay, this one's not too bad, because what I've essentially got is 10 times 9 times 8 factorial, which just cancels down with this 8 factorial times the 2 factorial. The 8 factorials are just going to cancel, so I've got 90 over 2, which is 45. Alright, actually what I'll do is I'll do the properties in a second in one go. So let's do the next one. 12C4 will be 12 factorial divided by 4 factorial times 12 take away 4, which is 8 factorial. Now we've got 12 times 11 times 10 times 9 times 8 factorial divided by the 8 factorial times 4 times 3 is 12, 4 times 3 times 2 times 1. And so straight away I can cancel the 8 factorials off, cancel the 12s off, and what we've got is, from here I can see I'm going to get 11 times 10 times 9 divided by 2, which is 11 times 5 times 9, which will give me 55 times 9, and that should give me 495. Yeah.
When did you get that other 12 from over there?
Alright, because I know 4 factorial is 4 times 3 times 2 times 1, and this part here is 12. So 12 times 2 times 1. And you can cancel it down. Yeah.
How do you know 11 times 10 times 9 is 11 times 5 times
Okay, because we know that 10 divided by 2 is just going to give us the 5. So I've brought, rather than deal with big numbers, I could do 110 times 9 divided, but I might as well just break it down to as many small numbers as I can, and then multiply them out. Okay, but there's another trick. Okay, the little tricks work like this. Can everyone look up? Trick number 1. If I've got 12C4, eyes closed, because I've got 4 at the bottom, I can write down 1, 2, 3, 4, time sign in between, right? 1, 2, 3, 4, and this. So this goes from 1 to 4, and then this just goes down 12, 11, 10, 9. And then from here I can just simplify down whatever I can. So 10 over 2, or 12, 4 times 3 is 12. So let's cancel those off. 10 divided by 2 is 5, so I end up 11 times 5 times 9, which is exactly what I've got there. Okay, so if I was to do 50C4, how can I write that out in fractions? At the top, what goes at the top? 50, yeah, 47. What goes at the bottom? 1, 2, 3, 4. And then obviously you just start messing around, so you can start dividing things by 2, dividing by 3, dividing by 4, and then reduce those numbers before you multiply them out. So that's the first trick. The second trick involves understanding Pascal's triangle and how it works. So if everyone just looks up, because this is quite important, especially when you get some algebra sort of problems, which I will try and give you probably today. Let me just take a snapshot of Pascal's triangle. So this is what we've got, and always bear in mind we always start with the rows always start from 0, and each term always starts with the 0th term as well. Now, what do you notice about this? No, the ones I'm highlighting. No, look, 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. 1, 7, 21, 35, 35, 21, 7, 1. It's a word beginning with S. Symmetrical. Okay? So what does that mean? Let's just pick this row here. This is row 4, 5, 6. So this is row 6. And what this means is 6C0 is the same as 6C6. In other words, 1 is going to be the same as this one here. It also means 6C1, okay, is going to be the same as 6C5. 6 is the same as this 6 here. 6C2 is the same as 6C4, and 6C3 is the same obviously as 6C3. But what that means is if we go back to the example before, 12C4, if I said work out, for example, work out 12C8, how could you simplify this? How could you convert this into an easy 12C4? 12C4, and then what would you do from here? Shivanji. Yeah, what's the trick? How many fractions?
4.
1, 2, 3, 4. What goes at the denominators?
1, 2, 3, 4.
1, 2, 3, 4. What's numerators?
12, 11, 10, 9.
12, 11, 10, and 9. And then you tidy it up and then multiply through. Okay? Yes? Right, that's fine. What you could do, what I'd suggest is, if the tricks aren't making sense, just at this stage, just use the formula. And the trick, you intuitively, once you've done a couple of questions, you might be able to just come up with them yourself. But I would suggest at this stage, if you haven't used the formula, please do use the formula. Okay, there's a lot of advantage in just taking the formula, substituting numbers in, and cancelling down. The trick is there just as a little bonus, you don't have to. Just one more thing, Laurentian, before I take your question, is that, do you know the first term? So if I say give me the first 3 terms, okay, pretend for n equals 5, okay, the 5th row. So if I do 5C0, what am I going to get? 1. If I look carefully, if I do 5C1, what do I get? 5. Okay. If I do 6C0, what do I get?
1.
If I do 6C1, what do I get? 6. If I do 50C0, what do you get? First term. 50C1.
50.
Exactly. So even then, when I say work out the first 3 terms of the expansion, the 0th term and the first term, when I equals 0, I equals 1, you don't even need to work them out. If you know what n is, well, the first one's just always going to be 1, and the next one's always going to be n. So all you need to work out is when r equals 2, the 3rd term. That's all you need to work out, for the first. So that's another little thing to point out. Did you have a question?
Yeah, say you have something, so you have, for example, NC16. Could you be able to do the trick by using 8 fractions?
It's NC16.
Yeah, so NC16.
Okay, so you'll have 16 fractions. What's n? What's your how many rows? Depends what.
I don't know, say it's, yeah, that's like 24.
All right, so if you get if you get 24, so NC16 is the same thing as 24C16 is the same as 24C8. Yeah? And then you could simplify that down to 8 fractions. So the point is, when you've got a big number at the bottom, you can turn it into a small number and then do your fractions and cancel off. And if that's failing, you're not sure, then by all means, please use a formula. I mean, the tricks, these numbers are there just as a little bonus. C1 is a non-calculator, but you'll come onto these anyway. Once you've done enough, once you substitute it into the formula, you'll probably see that you can cancel a lot of it down anyway. All right, what I suggest, we've got, how long? We've got about 10 minutes left. Let's have a go at doing some of these questions. Can you have a go at working on these questions here?